Patients with type 1 diabetes need to frequently pump insulin into their bodies. In order to know when to pump insulin, these patients have a continuous glucose monitor alarm, which detects incorrect levels of blood glucose. When that alarm goes off, the diabetes patient administers insulin manually through the pump. In an ideal world, the alarm would communicate with the insulin pump and cause automatic injections, creating a closed loop. But the world of outdated medical devices is not an ideal world. Dana Lewis is a developer of an open-source, closed-loop artificial pancreas called the Do-It-Yourself Pancreas system. Dana joins the show today to discuss how she hacked together her artificial pancreas using a Raspberry Pi plugged into these medical devices. This is a fascinating story of reverse engineering, Internet of Things, and the hacker mentality. If you're listening to Software Engineering Daily on a browser right now, whether it's on a mobile application or a desktop application, you might want to try listening on The Practical Dev. The Practical Dev has teamed up with us to give a better browser experience for listening to and reading our content. You can check out our new site at dev.to/sedaily. That's dev.to/sedaily. After a quick word from today's sponsor, we'll hear about the Do-It-Yourself Pancreas with Dana Lewis. Software engineers are always looking to automate their work. Software automation lets us get more done with the same number of resources. Investment automation works the same way. Wealthfront is an automated investment service that relies solely on software to acquire and manage client accounts. Traditional investment services have many humans in the loop, advising clients and taking fees. The problem with these older advisory services is that the advice that these services are applying is often so systematic that a computer could give the same answer, or an even better answer. Wealthfront takes a new approach with software-driven automated investment that provides better returns through software engineering. Go to wealthfront.com/sedaily to get a special offer for our listeners. $15,000 managed for free when you open your account. Don't pay commissions and account fees. Maximize your gains with Wealthfront's Set It and Forget It investment automation. Check out wealthfront.com/sedaily. It would support Software Engineering Daily, and it would also introduce you to the world of automated investment, so you can see if you like it or not. Wealthfront.com/sedaily. Thanks to Wealthfront for sponsoring the show. You've been a loyal sponsor, and we really appreciate it. Now let's get on with the show. Dana Lewis is a developer of an open source closed loop artificial pancreas called the Do-It-Yourself Pancreas system. Dana, welcome to Software Engineering Daily.
Thanks for having me.
I want to start with a brief scientific overview so that listeners who are unfamiliar with this condition and everything about it, could you explain what type 1 diabetes is and why you would build an artificial pancreas?
Sure. So type 1 diabetes occurs when your autoimmune system actually attacks your pancreas and it no longer produces insulin. You need insulin to unlock the energy of the food that you're eating. And so you have to give yourself insulin through injections or by using an insulin pump. That's the basics of type 1 diabetes. And most people probably know somebody who has it or know somebody who has type 2 diabetes, related but different conditions. But with type 1 diabetes, you have to give yourself insulin every day, and you also have to measure your blood sugar several times a day in order to decide how much insulin you're giving yourself so you give yourself the right amount. And so the point of why an artificial pancreas is because managing type 1 diabetes manually is a huge pain in the butt. The data between your different devices doesn't talk to each other, and you're basically doing this manual calculation hundreds of times a day. It's really frustrating, and so why not automate it if you can?
So what are the risks if you don't modulate your insulin correctly?
So you end up with either high or low blood sugar, and the symptoms differ from person to person. But for a lot of people, when they go low, their brain feels fuzzy, they shake, they sweat, and they just generally don't feel good. It's what a lot of people experience if they go, 12 hours without eating. You might feel a little bit cranky, what they call hangry. You just don't feel like you have energy, and you just focus on, I need food, because you know it's fuel for your body. Flip side, if you're high, a lot of people will develop a smell to the breath if they're high for a really long time. They feel really fatigued, lethargic, also cranky, but it's a different physiological feeling, because in that case, if you're too high for too long, your body actually starts burning off parts of your body to create that energy. So it ends up being really detrimental to your body over a long period of time, which is why it's so dangerous if diabetes is undiagnosed.
Is there a universally accepted way that people talk about treating type 1 diabetes, or is there some subjectivity to how different people treat it?
Well, if you have type 1 diabetes, you need to have insulin. That's pretty much what there is to it. There's no question about it.
Volumes of insulin?
Yeah, well, it's different for every person's body, and it also depends on what they're eating and activity levels. So some people, just because of their body makeup, may need 20 units of insulin a day. Some people with the same, body but different physiological needs, maybe 30 or 40. Then again, if you add activity levels, food, everything else, it can vary differently. So it's not so much about the total volume of insulin that you're getting. It's about getting the right amount for the food you're eating, the activity you're doing, and your body's needs.
Okay. So let's start talking about some of the devices that are involved in diabetes maintenance. What is a CGM alarm?
So a CGM is a continuous glucose monitor. And what that is it's a small sensor that you put in your body. The one I'm using lasts for 7 days, but you insert it with a needle, pull out the needle, and it leaves just a small filament behind. You attach a transmitter to it that sits there. It's waterproof, so it can go in the shower and the pool. And that transmits the data it's getting from beneath your skin to a handheld receiver. And that data goes every 5 minutes. And that's kind of like getting a moving picture of what's happening in your body with this blood sugar compared to doing a manual finger stick, which you might do 3, 4, or 12 times a day versus getting hundreds of data points, from your CGM. So it's a pretty drastic difference. But the reason the CGM is so great is that if you are trending low or trending high, whether that's from food, exercise, stress, any reason, ideally you can see where things are heading if you actually look at the device. You can do preset alarms, but it generally just alarms you if you've gone too low past this alarm that you've set or too high. So that's one of the challenges with this device, as great as it is that it doesn't give you any predictions of how low or high you're going to go. It's just saying your blood sugar is dropping or your blood sugar is rising. And the alarms, which you were asking about, they're good, but if you're sleeping and you're a heavy sleeper, you may not hear them. And that was my problem many, many years ago, is I would actually sleep through these alarms and go for hours with a really low or a high blood sugar.
Okay. What about the other devices? Like, how can you, if the alarm goes off, what are the other devices that you use to deal with this situation?
Well, you're not supposed to dose insulin off of a continuous glucose monitor. That's going to change. It's going to get FDA approved for that in the near future. But so an individual with diabetes would need to decide whether or not to balance that with a finger stick from their traditional glucose meter. And then they would need to potentially give themselves insulin. And a lot of people use what's called an insulin pump, which is a pager-like device. It's got a reservoir of insulin. It's got tubing attached to your skin. You change that site every 3 days, and it's constantly clipped to you and infusing insulin. But the idea is you would get an alarm from the CGM. You would do a calculation of, I'm dropping, this is how much insulin's in my body, this is how much food's in my body, this is what I'm going to be doing next, and then do a math calculation and then enter that information into the pump of, I need this much insulin. And there are some calculators on the pump or in apps to help, but again, it often doesn't have all of the data in it. So you're often transposing data from one device to the other, and then also adding other situational information that no device is going to have about what you're going to do next, for example, or what the weather is and how that might be impacting your blood sugar. But you use the insulin pump then to give yourself the insulin you need. So
is your typical workflow, like pre Do-It-Yourself Pancreas system, is the typical workflow you get an alarm and then you look at the data that the alarm is giving off and you use that to figure out what dosage you put in through your pump?
Exactly. And then I would do that, dozens of times a day. And then if you're sleeping, if you wake up, you may just be like, it's nothing, or you may have to do that. And it's really not pleasant to wake up multiple times in a night, every day for the rest of your life and have to make that kind of mathematical decision. You would much rather sleep.
Yeah, that's really intrusive. So there is significant math in converting like whatever the CGM alarm is telling you to what insulin dosage you should give yourself?
Yeah, and it's not that complicated of math.
It's just annoying over and over again.
It's just annoying. And if you're lucky like me, your ratios are really easy. For example, one of my ratios is 1 to 10. So it's pretty easy to figure out for every 10 carbs, I need 1 unit of insulin. That's pretty straightforward. If I need 42 carbs, that's 4.2 units of insulin. It's just a question of the timing. But again, it's just you do that hundreds of times a day. I've been living with diabetes for now 13 years. That's a lot of time taken away from daily life, and you don't really want to be thinking about it if you don't have to.
So why don't these devices talk to each other naturally right now?
Because they're made by different manufacturers. That's been the answer for the longest time, is every company has their own proprietary system. And, the company with possibly the pump that you choose may not also be manufacturing a CGM. The CGM company isn't necessarily a pump company, so it's always been disparate devices. And even when there's been a company that makes a pump and a CGM, it's kind of a walled garden of you might be able to see that CGM data, but it doesn't. You still have to go manually enter it across the other side of the device. It's really crazy. We're starting to see some progress in terms of what's going to come to market in the future, but that's exactly why I got started with this hacking, so to speak, or this configuration of my own devices, because it was very frustrating to have to do this jump across the walled garden or do it in my head over and over again. If I thought, if I could get the data from one device and the data from the second device, I could put it on my phone in the cloud. I could run predictive algorithms, get these predictive recommendations, and either use that to make better alerts so that I don't have to do the math. When I get alert, it tells me what to do, or to even automate it, which is what I ultimately ended up doing.
So what are these data formats like, these non-compatible data formats that you have to get to convert from one machine to the other?
It's not
bad. JSON.
It's not JSON. So just to understand the frustrations for the average person. So for the longest time, the only way to get data off my insulin pump, for example, the thing with the lethal drug, you would have to plug in this USB stick to your computer. You would have to set your pump by the computer right next to it, sometimes turn it over, get it in the right angle, and sit there and cross your fingers and hope that this JavaScript application from like 1990s would work. And 2 out of 3 times it didn't work. And that was just the pump. And then if you think about, in my case, the CGM I was using up to 3 years ago, the only FDA-approved software was on a Windows machine, and I had a Mac. So I couldn't get my own data off my machine for the longest time. And that's really what got me into this. Is I finally saw somebody via Twitter posted, hey, I managed to get Dexcom CGM data off in real time. And we tweeted him and said, hey, would you be willing to share your code? And what he had done is he had reverse engineered the way that Windows, that driver, pulled the data off the CGM and just wrote a script to pull it every 5 minutes when there was a new data point. And so I borrowed my then boyfriend, now husband's, old Windows laptop, put it in my bedside table. We ran that on an old clunky laptop, but we're eventually able to use other open source software using an Android phone. And later we're able to take advantage of other software to get the data off in real time. So it's not necessarily some complex piece of data. It's just I need this one data point and I need it every 5 minutes. And I don't need to have to be sitting by a Windows computer to get my medical data off of my device.
You mentioned that there is some signs that things are changing in the future. What's the stance of the device manufacturers for this type of insulin device hacking?
So there's a couple things here. The first is we're not necessarily hacking the devices itself. What we're doing is reading my own data off of it in real time. What I'd like to talk about, which is the automation of how I also send commands back to the pump, but it's not hacking. It's using the same commands I would use to press the buttons manually. It's just automation. So when we talk about hacking, it's more about hacking the interoperability and hacking the data out of the system so that we can run these algorithms that I built on it. So just for clarification there.
Sure.
So a lot of the device companies say, well, you can do whatever you want to your own body. But they also say, hey, we've got this something in clinical trials. It's going to come to market and, we're going to submit in 2017 or 2018. So they're like, we've got this thing. But when I started doing this work, and keep in mind, I said I've been living with diabetes for, 13 years or so. That's a long time to deal with all of this. So a couple years ago, I finally got sick of this. And with technology being the right place, right time, and social media, was able to say, I don't want to deal with this any longer. I'm going to, build my own system using a Raspberry Pi, using this horrible USB stick, which is now my favorite thing ever, to pull the data off in real time, run this algorithm, push it back. And the companies are kind of like, well, you can do that to yourself, but that's not something that we can support. And it's like, that's fine. I don't need you to support it. I just need you to not limit this type of features in future devices. And so a big part of where we are today is through this community's work is talking about all the benefits that come from open source, and access to an individual, a patient's own data is really, really big, but making sure that these new and latest devices that are going to come out in the next couple of years are actually still going to have the same benefits of being able to view what your data is, what decisions the machine is making, and why, so you can decide whether to trust the machine or, whether you need to intervene or not because you have this other situational knowledge. So it's progress, but I think it'll still be a couple of years before we get to a commercial device that has all of the data access and has all the interoperability. So you really can choose the best pump, the best sensor, and the best algorithm. Because that's right now what I'm doing is I've got the pump I prefer, the CGM I prefer, and the algorithm I prefer, which is mine. It's the only one available. But I would love for people to really choose the absolute best algorithm so that everybody picks the one that works best, and that ends up being the one that everybody uses because it's perfect. And same thing with pump and CGM. But because of the traditional manufacturing pathways, it's been, the person with the biggest market share, that's where all the pump business is, and they may or may not have a CGM, so you may or may not have to carry a separate device.
Okay, well, let's talk about that automation, like you said. Then we'll get into talking about the future and kind of the implications and where this is all going. But take me back to the earlier days of you said you found out about this guy who figured out how to pull the data off his CGM monitor in real time using reverse engineering on the Windows driver. So where did you go from there? How did that take you to the DIY PS?
So my original problem, like I said, was not being able to hear my CGM alarms. So my whole thing was if I could get the data on real time, I could use my iPhone, I could use my laptop, I could use an iPad, whatever device that I wanted or anybody wanted to make much louder alarms and make them vary. Because when you hear alarms a lot, you kind of get used to them. Like if you sleep through your alarm a lot, you might be the kind of person who needs to go and choose different alarms for different things to make sure that you wake up to it. So my original thing was just to make louder alarms. And the other reason I was so cognizant of this need is because after college, I moved to Seattle to work for a nonprofit health system here. I lived by myself. My family was in Alabama. And if something happened, I was kind of out of luck. And so for the longest time, my mom would actually text me every morning to make sure I was, quote, up, which is code for, hey, are you live? And, are you fine? Do you need any help? The idea being if I didn't respond, that she would escalate to calling the apartment manager, et cetera. And that was kind of my emergency plan. But at the time we started doing this hacking work, I was dating somebody who I thought, he lives 20 miles away. He's willing. It'd be great if he could see my data and he could get these alarms as well as my family in Alabama. That way, if I don't respond, he could then escalate with calling, and it'd be easier for him to drive over and knock on my door if I didn't answer versus my mom in Alabama trying to figure out what to do. So that's what we built, is this louder alarm system with the ability for other people to see my data. But I didn't want them to get alarmed every time I was 1 point above or below that threshold. That's kind of silly, and they would get alarm fatigue. So I added these snooze buttons, the idea being if I did wake up and I was fine, I could just tap a button that says I'm fine, snooze the alarm so it doesn't annoy anybody else. But the idea being if I missed an alarm and I kept missing alarms, it would then escalate to ringing them. And if they looked and said, oh yeah, she finally pressed the button, it just took her 10 minutes to wake up, or hey, she's still not responding, I need to call, we could do that. But again, if I did wake up and I was pressing a button, I decided I might as well put in exactly what I'm doing so they know that I'm awake enough to take the right action. They don't have to worry about me doing the opposite of what needs to be done at the time. So I added buttons for this is how much insulin I'm taking, this is how much food I'm eating, et cetera. And a result of inputting this data over time, we were actually able to build a prediction algorithm that says, because this much food, this much insulin, and what your blood sugar is, here's what's going to happen 30, 60, 90 minutes in the future. And we started being able to forecast, which none of my current devices could do. The current devices were all reactionary of, you did this thing 3 hours ago, this is how much insulin's left, or this is just what your blood sugar is without any contextual data. So I was basically able to amalgamate all this data from the pump, from the CGM, from what I was eating, and then do this forecasting, and then build these manual alerts so that if I was going to go high, it could tell me. And then also, because I was going to go high, this is how much more insulin I would need. Or if I was going to go low, hey, you need to think about carbs. And so it's able to ping me with these really smart contextual alarms to basically replace all that mental math I would have to do in my head. But the other benefits of this system is the computer doesn't sleep, it doesn't get lazy, it doesn't round up. It can be really precise about here's exactly what's happening, and here's, you need 3 carbs, you don't need 15. Because that's the other thing is there's this old antiquated diabetes rule of if your blood sugar is low, eat 15 carbs, wait 15 minutes. And the 15 was just kind of a guesstimate of you probably need that much if you're already low. And if you had no insight and you just knew that you were 60, that might be true. But if you're just dropping to 76 when 80 is kind of the minimum, you don't necessarily need 15 carbs. You might just need 1 Starburst, which is 4 carbs. So how great would it be to have a system just say, eat 1 Starburst, don't drink an entire juice box if you don't need it?
Well, was there some point along this where you were starting to think like, how have we not done this in the past as humanity? We've got these targeted ad systems that can predict everything about the world that's going to happen and how people are going to respond to an ad, but we don't have the most primitive. Maybe it comes down to the hardware and software integration, and that's just where the communication problem happens. But there must have been some point along the way where you were just like, why is this so hard? Why is this so difficult? This data is not very complicated. The calculations aren't that complicated, and yet I still have to do so much manual work. Was there ever like a moment where you just threw your hands up and you're like, why is it this way? What were the series of events that led to the world being this way?
So it's a couple things, and I kind of equate it to the boiled frog analogy, where if you throw a frog into boiling water, it says, oh, it's boiling, it's hot, I'm going to get out. But if you just put a frog in a thing of water, it's happy to swim around, it gets a little warmer, gets a little warmer. And that's what it's like when you're diagnosed with diabetes. You get in, you're like, oh, crap, water. But okay, I need to learn how to swim, and you learn how to swim. You learn how to deal. It sucks, but apparently that's what diabetes is. It just stinks a lot, and you have all this crap to deal with. And so over time, you kind of get used to it. So I think a couple things that factored into the kind of the big pivotal moment is when I met my husband, we started dating, and I pulled out my pump at the dinner table on our first date and, was giving myself insulin for the meal. And he said, oh, what is that? Is that a pager? I'm like, no, it's an insulin pump. We talked about diabetes, and as we started dating and our relationship got more serious and we talked more and more about it, so he would really understand what was going on, he'd be like, wait, your CGM doesn't talk to the pump doesn't, wait, what? And he comes from a tech background too. And so, but he had the perspective everybody else does when they hear about this, which is this is insane. Technology is so amazing, but what people don't understand is that all of healthcare, it's not just diabetes devices. All medical devices are like 10 years behind the curve on everything else. It's really frustrating. It has to do with the way manufacturers have their own little proprietary pathways. It has to do with regulations. It has to do with the complexity and the risk of what we're dealing with. Really frustrating for a number of reasons, but that was kind of the tipping point of, I know it's not optimal, but I have to deal with it every day, so let's not think about how much it sucks. And it wasn't until, again, we saw that person on Twitter, we saw that first glimmer of, somebody finally freed the data, that we thought of, okay, let's see what else we can do once we freed the data. So that was kind of the tipping point, and social media played a big role in, somebody sharing their discovery, because it's not like people didn't have these ideas before in terms of bringing all the data together. Scott Hanselman, if you know of him, is a great example. Mm-hmm. He's written for years about the horrible state of diabetes technology and all these ideas people have had and things he's hacked together. But because of technology not being where it is today, and also social media not being where people can connect, these ideas, they might have helped 1 or 2 people, but they really didn't go anywhere. So social media was like really the big connector in terms of allowing us to discover somebody else's work, but also allowing us to distribute our work as well, having other people use it, but having other people come on and join the project and contribute to it in a true open source fashion.
Wow, that's very cool. So this idea of a closed loop, give me an idea for the vision of the closed loop that you have. I know you've kind of hinted at this at this point, but give me an idea of what the closed loop looks like and how that contrasts with how things are kind of in the status quo.
Yeah, well, we've already talked about the status quo a little bit, which is you might have a pump, you might have a CGM, but you are the human in the loop. You're basically taking data from one system to the other, running the math, pressing the buttons, reading data, over and over and over again. And it's silly because we could totally automate that. So what the closed loop does is it automates that. It pulls data off of both devices, it runs it through this algorithm, and it generates a recommendation of you need to take this action. But again, instead of my first system, which said, hey, Dana, take this action, it says, hey, pump, take this action. And we've actually now programmed it using a Raspberry Pi as the mini computer and the mini processor to actually send commands via the CareLink Stick to the pump directly. So it reads data off the pump, the CGM, runs the algorithm, says you need a little bit more insulin or a little bit less insulin based on all these variables and all these factors. And so it just sends a minute temporary basal adjustment command. So this adjustment to, you need a little bit more, a little bit less, enacts it. 5 minutes later, gets another data point, does the same calculations over and over again. It says, yep, keep going, or, oh, you need even less now or even more now, and just does it over and over again. Again, the idea being that it's not lazy, it doesn't round up, and it just does it over and over again. But then everybody's first question is, oh my gosh, it's so risky. But there's a couple things. First of all, we design for safety. We assume that the last command it sends is the last command it'll ever get. So it's the absolute possible safest thing that the system could ever send. So that's kind of first and foremost. Number two is we designed it so that, it's really, really conservative, really, really safe. You can't get stuck in a loop and it send just huge amounts of insulins over and over again. There's a hardware limit on the pump as well as in the software. So there's safety limitations in terms of that. But it's also so much safer than you waking up in the middle of the night and in your sleep pressing buttons on your pump. And that's something that I've done as a human, as I wake up and I hear alarm and I'm like, oh, I probably need some more insulin. Button. Oh, okay. And there's been cases when there was no alarm and I just woke up and felt funny and
wow.
did that. So there's all these scenarios where diabetes is a long series of adverse events. And so, yes, automating a system is risky, but overall, it lessens the overall risk of living with diabetes and cutting down on a lot of the highs and a lot of the lows and a lot of the overdosing and underdosing that happens, because otherwise your pump is just pre-programmed to always do the same thing, no matter if you're sick, you just ran a marathon, you're in a different time zone. There's all these different things that can adjust your body. And it's a lot of work to stay up on all of them.
It's basically the self-driving car versus human-driven car argument.
It's a great analogy. It's like if you were trying to drive down the highway at 70 miles per hour and you wanted to stay exactly at 70 miles per hour, if you were not on cruise control, what would you do? You would look up the road, you would look down and say, oh, I'm 69, I need to go faster. Look up at the road, look down. Oh my gosh, I'm going 75. I need to slow down. Up, down, up, down, up, down. That's really exhausting. And so you might choose to sacrifice of like, oh, my speed is going to fluctuate, or you might set cruise control. So the closed loop is the equivalent of setting cruise control of, oh, you're speeding or your blood sugar is too high, you need a little more insulin or a little less insulin. And that's the whole idea, is basically pulling the data into a system with the associative hardware to enable kind of a cruise control. You still have to take action. You still have to monitor the system. You're still driving the car. You're still aware, but it's a little bit less of a problem. And then in the case of diabetes, when you're dealing with your blood sugar, it's absolutely critical that you keep your blood sugar within a normal range, because it affects how you feel and how you function throughout your entire day. So there's both short-term and long-term implications of it.
Let's talk about the hardware a little bit more. You have the different components. I think if I have these correct, is you have a battery, a Raspberry Pi, a CGM monitor, a CareLink, and an insulin pump. Are those all the components of the system? Yep. Mm-hmm. Okay, so explain how those different components play their different roles.
Sure. So the insulin pump, like I've talked about, is what's pre-programmed to automatically dose me with insulin. The CGM, or glucose monitor, is reading back my blood sugar. So it's kind of like the output of the system every 5 minutes. The battery powers the Raspberry Pi, and the Raspberry Pi is the brains where the algorithm lives. So it, using with the CareLink Stick plugged into the Pi, it can read data from the pump, and you get data from the CGM and feed it into the algorithm on the Raspberry Pi. It runs through the algorithm and says, okay, you're predicted to be high or low, you need more or less insulin. And so then using the CareLink Stick, it communicates to the pump that says, do more or less insulin.
CareLink does what? Like, what does that do?
It's a little radio stick. It's the proprietary radio stick that goes with my insulin pump. We've actually are at the point now where we've replaced it with some other sticks that are possible. Different radio sticks that people have played with, whether it's an ERF or a slice of radio or a TI stick or, you name it. But the idea is it's just a radio stick to communicate with the pump. And it's the first one that we use to reverse communicate. So that's what most people know it as.
Oh, I see. Okay. So the pump is like permanently installed on your body, and the CareLink stick is the thing that communicates with it? Is that?
Well, the pump is clipped to your body, and you've got tubing and a site attached to your body. That's every 3 days. So when you say permanently, it's not like it's embedded, but yes, right. Your pump tends to be on your body or, next to you in the bed. But the CareLink stick has a range of 2 or 3 feet. It's not that great, so it still has to be close in range. Some of the other radio sticks have a better range that can read across the room, for example. But the idea being, if the Pi is powered and the CareLink stick is plugged in and within range, and the system can get all the data, it can then communicate these actions back to the pump. And that's, again, this ideal closed loop system where it reads data, it sends command, it confirms that it happened, it readjusts the predictions, it gets a new data point, and it does that system over and over again, dozens of times an hour versus you as the human having to do that over and over again.
Do you notice when it happens? Like when an alarm goes off at this point, or does it just silently go off and communicate with your insulin pump?
It silently goes off and communicates with everything. So that's one of the challenges of the system is you would have to remote in to the server logs to see, is it running exactly what is running? Where's the hang up? Or the pump actually will do a little circle on the screen if it's doing a temporary basal rate. So I'd be able to look down and look at the pump and say, oh, yep, it did a temp basal of 1.35 units 1 minute ago. So the system is live and working, communicating. Or I can remote into the Pi to see what's happening, for example. But generally, if you're in range and you know what's working, you just let it go. And you might occasionally check your blood sugar like you would otherwise, but you're not really getting alarms per se, unless it's system alarm saying it's not working, because your blood sugar is otherwise being, modulated by the system automatically.
So my impression is that this has tremendously improved your life. Could you give me an idea for how your day-to-day existence has improved from this device?
Yeah. So just remember the analogy we talked about with the cruise control and driving the car at 70 miles per hour. Imagine doing that all day, every day for 10 plus years. And there's going to be times where you choose like, hey, I'm not going to care about my speed. I'm just going to, focus on driving and enjoying the ride. And you can do that. But at some point, you kind of have to pay attention to your speed and where you're turning and what you're doing. And so diabetes kind of takes up a lot of mind space. And with overnight, a lot of times I would just, before I had the system, I would just kind of, here's what my blood sugar is. Here's what I think is going to happen. I'm going to cross my fingers, go to sleep, and hope I wake up in the morning. Because it's a sad reality that some people with diabetes end up dying in their sleep if they have really, really bad low overnight. And that was my fear of what would happen. So with the system, the biggest benefit to me is I get overall better blood sugars, but the peace of mind of being able to go to sleep and turn on cruise control and not worry about setting an alarm, waking up, feeling bad, dealing with the impacts of that in the next day, it's huge. And for example, when you wake up in the morning, what do you think about? You think about, how's the weather? What am I going to do today? Did I get enough sleep? Most people with diabetes wake up and they have to think about, okay, how am I feeling? What is my blood sugar? What do I need to do? How much extra time do I need to take to fix whatever bad happened in the night? Now with my closed loop system, when I wake up in the morning, I don't think about my blood sugar first thing anymore. It's really a dramatic difference of I think about what's on my schedule and what I'm going to do and what I'm looking forward to. And then, oh, by the way, I need to test my blood sugar, calibrate the CGM, see what the system did. But my blood sugar has been perfectly within range all night long. And it leads to feeling very physically different. I compare it to starting the day with a handicap. If you had a low blood sugar overnight, you got less sleep, you physically feel bad, and you're starting the day with a handicap compared to somebody without diabetes and a working pancreas who wakes up with a normal functioning body. It's just very, very different. And there can be multiple days a week on average that you would wake up feeling poorly. And it makes a huge difference in terms of your quality of life of you not having to worry about all that and not to physically feel bad.
So there have been software jobs where I've had an on-call role and where when I wake up, certainly gladly the first thing I think about is not anything related to my health or insulin. But when I'm on an on-call duty, I'm often thinking, is the software that I'm working on functional? Is the thing that I changed yesterday functional? And I imagine if I were responsible for software that kind of monitored my pancreas data or communicated data about that, I would wake up somewhat concerned about software bugs on occasion. But maybe you've had it for long enough where that has gone away. Or are there still software bugs that you worry about or that have occurred that have scared you? Do you have any stories about bugs?
So for context, this was a very iterative build. If I built this alert system, I built the algorithm, I tested it for a year before we decided to close the loop. So I had years of experience of this thing really, really works. When I do what it says, the outcomes are great. When I ignore it or I am stubborn, it's less optimal. So I had a year's worth of this algorithm that we built works really, really well. So when we switched to the closed loop, I was expecting to do a couple nights where I would set the alarms, wake up, see what was happening. But this was a benefit of having, somebody who loves me support me, is that he could stay up awake 20 miles away and watch remote, and I could sleep. So I had support in that sense of that my then boyfriend 20 miles away would be able to watch the system.
So he had some dashboard open, just like monitoring it remotely.
Yeah.
Wow.
I would go to bed. He would stay awake and, look at it, that kind of thing. And now it's even easier now that we're married because, he's in the room. He had an incentive to build the system faster because when we got married and we're living together, he didn't want to deal with all the alarms and all the chaos. So he's got a lot of incentive also to help me keep the system running. But, there were maybe one or two things in the very early days, but that was more about usability of keeping the pump in range of the CareLink Stick. That was the biggest issue, was just keeping it in range, making sure that the Raspberry Pi SD card didn't get corrupted because of power fluctuations, because I was running my battery down, just general usability things and less about the actual algorithm. But again, I was the co-creator of this algorithm. It's different for somebody who now comes and decides to build this type of system. So for context, what I built myself is what we call the Do-It-Yourself Pancreas system, or DIYPS. But I can't distribute this because that would be distributing a Class 2 medical device. Can't do that according to the FDA. But what we chose to do was create kind of a movement called Open APS, which stands for Open Source Artificial Pancreas System, with the idea being that there is learnings we've done from this year of building the system that other people should be able to leverage. So we wrote a reference design, and we actually eventually built a toolkit with somebody called Ben West, who spent years building some of the tools that we leveraged for our system. And put this on GitHub. It's publicly available. Go to github.com/openaps to see it. But then later pieces of the code, so that if somebody wanted to go off and build it themselves, they would be able to, and they wouldn't necessarily have to build their own algorithm. They totally could if they wanted to. They could use the bare bones structure and put in their own algorithm. But most people don't want to spend a year or weeks or months building an algorithm, and they don't necessarily need to. The idea being that if they want to walk through the code, read through the system, do lots and lots and lots of testing, they could decide to build their own system. And that's what's happened is actually, as of today, we're now at 51 people around the world, both adults and kids, who are using the system to automate insulin delivery for themselves, but it's a total DIY effort. And that is concerning because, our pieces of our code and our system are out there, but it's something that I'm absolutely using and have used every day for the last year plus. And because it's open source, it's beautiful that other people can review the code. They can criticize it. They can run unit tests. They can try to, do their own thing. They can also choose not to use it. So for anybody who does use it, they have intent to build the system. They spend a lot of time and energy building it. It's not like you press a button and you get it, or you fork it and you get it. They have to get the hardware. They have to do a lot of integration to make it possible with their series devices and do the testing, and they have to choose to trust it. And that process is a little bit different for everybody, but because it is such a labor-intensive and challenging process, that reassures me that the person knows what they're doing in terms of deciding what works for them or not. So there could be bugs still there, or it could be introduced, but that's kind of the beauty of what I see of open source. This is my first big open source project, but it's really neat to see the community contribute with different skill set to say, hey, I'm going to write unit tests, or hey, I'm going to run this on, a database of data versus, a live system, or I'm going to build a new hardware component, or, I've got this feature that I want to test, or I want to visualize this data. There's all these different pieces where people have come in and contributed their work, and it's really beautiful to see. And that makes me feel better because it is really a community project. It's not just about Scott and Dana and what they did, but it's really about this community's body of work that enables this. So that makes me feel better in terms of thinking about bugs and other things, because it's on each individual person to build and test and vet and decide to trust or use this system. It's not ever something that I'm saying you should use this or I'm pushing it on anybody. It's something that they completely do on their own, which has benefits in that regard, challenges for sure, because it means it's harder for more people to get, but that it kind of balances things out.
So you're talking about this community, and you have said that your community has this kind of N of one mentality. And I really like the idea of the N of one experimentation. Explain what that means. What is that ethos of the N of one?
So the N of one is this idea that, I cannot give this to another person. Because that would be distributing. And so we really emphasize this N of one to be, I am this individual choosing to do something off-label. It's not supported by the device manufacturers. The FDA has not vetted this, has not tested this. The risk is on me to do something to myself, which people do all the time with diabetes. There's drugs that they take off-label with their doctor's help, or they tweak their ratios, or they change something on their pump, or they understand that when the moon is full, I need 2 times more the amount of insulin, just for whatever reason. That happens all the time.
Yeah.
So it's not, if you know somebody with diabetes and you see how much they experiment and they tweak things on their own anyways, it doesn't really sound that strange. But if you don't understand diabetes, it's kind of like, whoa, these people are hacking their devices. They're doing all this stuff. But that's exactly why the N of 1 is important, because people need to decide what works best for them. And that's what we really encourage. And so if you look at openaps.org, if you see us talk about it, it's always N of 1 times 50 or 51, or back when we started, it was N of 1 times 4, because it was 4 different individuals who might have used our reference design, might use some of the code, but they built their own implementation. They absolutely did that thing themselves with the hardware and the software and everything else. And that means that not every system is identical. But it means that it's their own and they chose to do it. So that's the very, very important piece of what we're doing, even though we're a very strong, close-knit community and completely transparent and completely open. Anybody can pop in our chat channels and see who's working on what, who's coming in and building the system, what the questions are, what the challenges are, and that kind of thing. But it's pretty important for everybody to do it themselves and to emphasize that N equals 1, because again, you don't press the green button and get a pancreas.
Well, the N of 1 thing, I think of it as more of a way to live your life. And I feel that perhaps we were raised or educated with this mentality that you trust this giant ball of statistics that is supposed to tell you how science works, how the world works, and in actuality, there are many cases where the sample size is not big enough, or it never will be big enough, or the way that you should model something is through time, modeling your own since your own body is so much different than anybody else's body. The way that you should model a large sample size is that body through time, rather than that body contrasted with a billion other bodies, which I think some people don't really appreciate, and they don't really get that mentality, that statistical idea. I don't know. Do you get that sense?
Yeah, and I think the other important thing to remember is that people with diabetes are not static. They're not the same over time. I was diagnosed when I was 14. My body now, 13 years later, I am taller, I'm bigger, I'm older. Now I've run a marathon. I didn't before. And so my needs and my body's physiological makeup and where I am in the world, before I was a high school student, now I'm, adult with a job and a travel. It's very, very different. And so people with diabetes, in terms of their cycle of where they are in their life, is also very different. So thinking about the needs and how that evolves over time is really important. And I think that's something that gets left behind too, is when we think about medical device, it's not you get that one device and that is your thing for the rest of your life. Based on lifestyle changes, you may need different devices, or you may need more or less interaction with those devices depending on what your body is doing or how much control you want to exert over the devices. And that's something I think that is often overlooked and really frustrating. And I think I mentioned Ben West before because he's been instrumental in terms of he spent years hacking and understanding how these pumps worked before Scott and I got there, and we're able to leverage a lot of his work. But he often says, we have to trust our devices. They're giving us this lethal drug. And we have not been given any reason to trust them. Trust us, it works. It's really, really hard to do. And that's kind of what the FDA is there for. But there's still so many things that can go wrong in life with diabetes. It's really frustrating. And I think the world is, and especially the industry, does not give individuals with diabetes enough credit to test and validate our own devices and be given the tools to test and validate our own devices to make sure that they work for us in this changing dynamic. Because right now, kind of the way the time cycle is on buying these devices and it being like a 4 or 5 year warranty and then being really outdated technology, it's really, really not ideal, and it's really frustrating.
Yeah. And so is that what, there's this open source movement that you talk about. In fact, you're giving a talk at OSCON, which is the O'Reilly Open Source Conference. What are you going to talk about at that conference? How does this project and your perspective on open source, how does that play into this larger conversation of open source's influence on healthcare?
Well, it's going to be exactly that, which is, I think OpenAPS is one of the first really prominent examples, and part of that is because of the way I and we use social media to really communicate and be out there. If you follow us on social media or check it out, you'll also see this hashtag called We Are Not Waiting, and that's really what I'm going to talk about at this conference. Is that we are not waiting in healthcare. It looks diabetes, but it's really it could be for dialysis or asthma or cancer or people dealing with pacemakers, that the technology is there now. We have the know-how as patients, as individuals, where we don't have to wait for companies to create a device or create an algorithm or create the software necessarily. In some cases, maybe, but there's a lot that can be done by us, and using social media and open source, we can actually communicate out, here's what's possible, here's what we've done, here's what needs to be done, here's how we can collaborate together so that everybody gets more access more quickly and can also test and validate the devices that we are given from manufacturers. It helps everybody. It helps the FDA, it helps us as patients and loved ones, and it helps the manufacturers too. But that's really what I'm going to talk about, is kind of telling this broader story, but kind of drawing the line and saying, this is not just a unique special case. It's happening more and more across other areas of diabetes, other disease cases, and other parts of healthcare, where you're starting to see hospitals with innovation labs put things out under the MIT license. So they can say, like, look, we're going to use it in this case, but feel free to use it however you see fit. And I think that's starting to see more and more promise. And I'm hoping to see actual manufacturers start to maybe can't adopt open source, but embrace it in terms of partnerships with open source projects or people involved in those projects, because the more ideas, the more progress, the more work we do on this, it's only going to help everybody.
Yeah, so the way that open source and enterprise works in software is typically there's this flywheel between somebody comes up with an open source project, some enterprise decides they're going to monetize it, and then in order to monetize it effectively, the enterprise has to give back to the open source community to kind of drive the community, and so that the community will kind of respond back to the enterprise. And that sounds nothing like health today, but I could totally see that happening in the future.
Yeah, there's actually a really great example in the diabetes space. There's a nonprofit that was created called Tidepool, which does everything open source. So their code base is open source, but their focus is on creating better tools. And mostly right now, they're retrospective analysis tools, but it's still really, really needed to be able to pull data from any device off and view it all in one place. They're doing some really great work, but they're modeling being an organization, but they're doing it open source so that if an individual like me says, hey, that's really cool, but I want to do X, Y, Z, if it's not on their roadmap, I can take it off and do that. And I can always, submit a feature back to them and they could choose to integrate it. But I think that's one small example of the more focus I hope to see. And that's why I also think a big part of what we're doing now is not just, okay, we built the closed loop system, but a big part of what I think is our priority is, again, not just encouraging other people to check it out and consider if it's right for them, but working with manufacturers, working with the FDA, working with the industry to kind of explore some of these ideas of how could we do some of this open source stuff that works really, really well elsewhere. Yes, there's risks. Yes, it's medical, health data, privacy, HIPAA, blah, 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 blah. I get that all, but that doesn't mean that nothing can be done. And so let's start small, but let's start with something and use that open source mindset of, like, if you find something, like, create a bug list, fix it, knock it off one by one. Don't wait until you have the perfect solution, because then you're going to be 10 years out of date. And especially with technology happening, that's already the status quo. So we want to see what we can do to change that.
So I want to begin to close off. You are not an engineer by trade, but you have this hacker mentality that you've described. And my perspective on the hacker mentality is it's really about self-empowerment, and it's about kind of being skeptical of conventional ways of doing things and deciding that you're going to do things on your own. Do you think everybody should adopt the hacker mentality?
I think everybody with diabetes already has the hacker mentality in terms of everybody in the world. I think it's a really valuable perspective to have, and not so much in terms of, you don't always have to do the things that you say, there's something wrong, this needs to be fixed, and you could choose to do it. But I think what's most important and what's most valuable, and I love seeing in other people, is this perspective of, let's think critically about it. And if there's something that I decide I need to do, let me figure out the tools I need. Let me learn the skills to do that. And that's what you see in Open APS is people who come in without a technical background and they say, hey, there's these Lego building blocks of code, of algorithm, there's instructions. And yes, I need to learn some Linux command line stuff, but that's doable. You can learn how to change directory. You can learn how to, grep a log. I mean, there's all this stuff that you can learn how to do that doesn't require this really, intensive engineering background or experience. It's just the willingness to say, I don't know yet, but let me figure out how, or can you help me? And that willingness to learn. And I think as we hear more and more people say, oh, you need to learn how to code, that's actually what I would advocate is we don't need to teach people how to code. We need to teach people how to learn things that they're not familiar with and experience with. And sometimes code is a proxy for that. Because once you kind of figure out how to learn to code one thing, you kind of figure out how to learn and teach yourself this other stuff. And that's how I kind of came about is my undergraduate program at the University of Alabama was in the computer-based honors program. And you spend the first semester learning Fortran 90, the second semester learning C++, and then you spend 2 years doing undergraduate research program projects in technology in your area of interest. But the idea being, if you can learn those two languages that nobody's really using Fortran 90 these days. You can teach yourself HTML. You can learn how to use SPSS. You can learn Python. You can learn PHP. And that's really paid off for me in this project. But that's kind of the mentality I try to tell other people is I did not get an engineering degree. My day job is not engineering. But that doesn't mean that I couldn't build this system. And it doesn't mean that you couldn't leverage what's out there or any other type of open source project. And that's what I would love to see us encourage more people to do is have this mentality of, let's figure out a way to learn what we need to do it, because amazing things are possible if we do that.
All right. Well, I love that. Well, thanks, Dana. Thank you for coming on Software Engineering Daily. This has been a great conversation.
Thanks for having me.